Our project is on ESP alternatives and monitoring. Our team members are John Michael Domingo, Kelly Keene, Kevin Kovacic, and Ben Schwim. Hydrocarbon reservoirs naturally deplete over their life and lose the ability to flow fluids to the surface without assistance. At that time in the reservoir's life, artificial lift technologies must be used to maintain a well's production. Electrical submersible pumps, or ESPs, are often a preferred artificial lift method due to their ability to deliver higher production rates. However, ESPs are not as economical as more conventional lift methods, such as a gas lift, when the total installation and life cycle costs are compared. The life of a conventional ESP is typically short given its complexity and harsh operating environment. Therefore, there is a need to recognize and predict applications that may arise in the use of ESPs in order to improve their reliability and to prevent failures. There is also a need for alternate deployment methods that will eliminate the need for a heavy rig to retrieve ESPs. Rigless ESP deployment and retrieval methods minimize deferred production and operating expenses associated with the heavy rig intervention. The purpose of this project is to investigate alternative methods of deploying ESP equipment in order to determine the most economically efficient option that also maintains a high standard of performance. Additionally, this project will investigate methods to better monitor the daily operations of ESPs in hopes of being able to recognize potential issues before they can negatively impact the cost or performance of the job. The business need for this project is to make ESPs more economically beneficial and reliable. There are two business objectives. The first objective of this project is to show why ESP alternatives should be considered over conventional artificial lift methods as it pertains to reservoir recovery, production of a well, and possible economic benefits. The second objective of this project is to use ESP monitoring to recognize, predict, and prevent complications that may cause equipment failure. For this project, we will be reaching out to service companies to obtain adequate information on all ESP tools and application methods currently and historically in use. We will be obtaining historical data taken during ESP operation and analyzing it to determine the methods and tools most effective and economical. Additionally, we will be collecting and interpreting data from the monitoring systems of ESPs in order to create a plan to recognize potential issues to avoid ESP repairs or replacement.
There are two main objectives associated with this project. Firstly, we will be researching ESP alternatives and how they can effectively be used to increase the life of the well. In order to consider this objective successful, enough field data will have to be collected to adequately indicate economic benefits for the use of ESP alternatives as compared to conventional ESP methods and other artificial lift methods. Additionally, another objective is to research ESP monitoring and look at data in order to determine a more effective method of monitoring. For this objective to be considered successful, monitoring software have to be successful in determining anomalies during the operation of ESPs, which will mitigate troubleshooting and replacement. The initial requirement of the project is that individual team members exhaust all available resources related to gathering and interpreting data in order to contribute to the final report and presentation of the project. All alternative ESP deployment methods must be thoroughly investigated and all aspects must be compared unbiasedly. Team members will also be required to strictly adhere to deadlines in order to keep the progression of the project on pace for completion. There are several constraints and assumptions associated with this project. Firstly, we must obtain field data on the monitoring of ESPs while adhering to company guidelines and restrictions related to confidentiality. Secondly, we must obtain the proper programs and equipment necessary to analyze and interpret acquired data. Also, time constraints between group members and industry advisors must be considered. In reference to assumptions, we will assume that ESPs are the preferred artificial lift method. Also, we are assuming that the opportunity exists to improve upon existing methods and that prolonging the life of an ESP will prolong the life of the well. First half of the project will focus on determining the optimal ESP alternatives in order to maximize reservoir recovery and production, which in return will increase the economic feasibility of a well. The second half of the project will focus on developing a monitoring system to detect possibly anomalies in daily operation of an ESP. Detecting these anomalies could minimize ESP complications that could result in an ESP maintenance or replacement.
There are three major risks related to our project. The first is obtaining a sufficient amount of reliable data to support the claims we are attempting to prove. Due to the fact that the technology we are investigating is relatively new to the oil and gas industry, there's minimum historical data and field studies available. Secondly, our lack of previous knowledge on the topic puts us at risk of being ignorant to the full scope of all alternative and monitoring aspects associated with the use of ESPs. Lastly, due to the fact that ESPs are primarily used offshore, our inability to physically be present and make observations during operation is a risk. The project deliverables expected by our stakeholders include a high-level and detailed report and presentation on all aspects of ESP alternatives and monitoring. The report is to include the proper use of ESP alternatives as it ascertains the economics of a well. Furthermore, it will include monitoring methods that will focus on minimizing ESP restarts, which can potentially improve the lifespan and reliability of an ESP. The overall report and presentation will show the customer, project sponsor, and stakeholders that ESPs, although more expensive than and not as common as other artificial lifts, can be reliable and economically beneficial to the life of a well if properly applied and monitored. A recommendation will be made on the most efficient option when using ESPs, as well as a plan to better monitor the daily operation of ESPs in order to recognize and predict potential issues that will negatively affect the well. Our summary milestone schedule is heavily weighted in the project planning semester this year. We expect to have a milestone completed about every 2 weeks for the next 6 weeks. This is to get our project rolling and allow us to reevaluate which areas may require more time before the end of the semester. We plan to create another schedule at the beginning of the new year related to the execution phase of our project. Our budget is made up of 3 items. The first is a professional textbook recommended by our industry advisors for its invaluable information on the topic of ESPs. The second is the MATLAB program, which we have been told is necessary to analyze the given data for pump monitoring. Finally, we have estimated the cost of traveling to meet with our industry advisors face-to-face in both New Orleans and Houston.
The principal project approval requirement for the project will be to deliver a professional report and presentation outlining ESP alternative deployment methods and monitoring. For ESP alternatives, the report and presentation will include a brief overview of conventionally deployed ESP methods and their applications. Furthermore, it will include a detailed description of alternative deployment methods of ESPs while considering the following: reliability, intervention cost, deferred production, complexity and risks associated with intervention, and power requirements. For ESP monitoring, the professional report and presentation will show the results from monitoring the ESPs. The results from monitoring data will highlight anomalies detected in normal operations, which will be used to help minimize the number of startups required, potentially extending the life of the pump. The project manager for this project is Kelly Keene. As project manager, Kelly will have the following responsibilities: communicate with team members in order to set up appropriate meeting times once a week that will be convenient for every team member to attend in order to discuss the progression of the project. Evenly distribute tasks amongst group that will help the project progress into its final presentation. Create a project timeline to ensure all tasks are completed thoroughly and in a timely manner. Ensure that there is open and consistent communication among the group about the progression of the project and status of upcoming tasks. Inform industry advisor during the course of the semester of the project progression and upcoming deadlines. In summary, this project will fully investigate conventional and alternative ESP deployment methods used for artificial lift in order to determine the most effective practices and equipment. It will also investigate the monitoring systems associated with ESP technology and provide a method to recognize potential failures or issues before they occur. In doing so, we hope to increase the lifespan of ESP technology and, as a result, increase the life of the well. Ultimately, we hope to increase the overall efficiency in using ESPs in order to ensure a company is operating at maximum efficiency.